Okay guys and girls, so I had to split this PowerPoint. So again, we left off with beta decay, and a beta particle is a fast moving electron which is emitted from the nucleus of an atom undergoing radioactive decay. So normally you don't find an electron in a nucleus, but when you have a huge unstable nucleus, it emits a positron which decays into a little beta negative electron. So, as a result of beta decay, the nucleus has one less neutron but one extra proton. So the atomic number, typically represented by Z, increases by 1, and the mass number, represented by A, stays the same. So let's see what that looks like in an image. So if you have polonium, which has a mass of 218 and an atomic number of 84, and it decays into astatine, the mass number stays the same, but you can see that the atomic number increases by 1. Wait, let me say that over. So you've got a polonium that decays into an astatine and a beta particle. So what happens here is that the mass number stays the same in the new element, which is astatine, but the atomic number increases by 1 by the beta. So in a beta decay reaction, you always have the atomic number of the new element increased by 1. And again, the atomic number tells you which element it is. So let's look at some examples where you have to guess which element it is. So if you have X that decays into Y and a beta, if you look at that a little bit differently, you can see that polonium, which is X, decays into radon and a beta, and you can see that the mass number stays the same and the atomic number increases by 1. In this example, thulium decays into an unknown element and a beta. It's very easy to figure out which element this unknown is because you just write down the mass number as the same and the atomic number increases by 1. And so thulium 90 becomes 91, and that is palladium on the periodic table. Some more examples: if you have an unknown element that decays into lead and a beta, it's very easy to determine what the unknown element is because you subtract your beta from your atomic number, and that tells you that it's 81, and this is thallium, and the mass number would stay the same. All right, bismuth decays into an unknown element and a beta. So it's very easy to tell. You just write down the same mass number and the atomic number would increase by 1. So going from 83 bismuth to 84 polonium. If you have an unknown element that decays into a bismuth and a beta particle, it's easy to determine what the unknown element is because you just rewrite the mass number as the same, and then you subtract your beta, and that will decrease your atomic number by 1, letting you know that it's lead. Okay, so just in a very short recap, for alpha particles, in order to identify an unknown element, you know that the atomic mass number is going to change by 4 because that is the mass of the helium or the alpha particle that you get, and the atomic number is going to change by 2 because that is the atomic number that represents the alpha. With beta radiation, the only thing that is going to change is the atomic number, and depending on which side of the equation it's on, it's either going to increase by 1 or decrease by 1. With gammas, gamma rays are the most penetrating form of nuclear radiation. Most of us already know that. They're electromagnetic waves, which means that they travel through space with the highest frequencies and the shortest wavelengths, which makes them very incredibly high energy. A gamma emission, it's the tremendous amount of energy, but it has no charge. You can see that there's no charge here. It will only be stopped by concrete or lead. And so the gamma symbol is this strange looking Y, and it has no mass and it has no charge, so it is not going to change in an equation the atomic mass or the atomic number. So thick blocks of dense materials such as lead and concrete are required to stop gamma rays. Gamma rays, though, cause less damage to biological molecules inside the body as they pass through, and that is why they are used in radiation treatments. Okay, so what does gamma look like in an equation? You don't really have to solve anything because it has no mass and no charge, but you do get a photon, which is represented by this Y. So gamma particles are typically emitted from substances like iodine-125, iodine-131. Remember, those are isotopes of each other, different numbers of neutrons. Cobalt-57 and cesium-137. Gamma rays are not charged particles like alphas and beta particles. They are electromagnetic radiation. They have a high frequency. And when atoms decay by emitting alpha or beta particles, they form a new atom. And the nucleus of the new atom formed may still have too much energy to be completely stable. And that's when you get your gamma. So in summary, nuclear decay happens with an unstable nuclei, and matter and energy are emitted. Alpha particles are large, they look like a helium atom, and they can be stopped by a piece of paper. Beta particles emit a proton or a positron, which becomes an electron and can be stopped by aluminum foil. And gamma particles can penetrate almost anything except for lead or concrete, and they emit tremendous amounts of energy. Transmutation is the decay of the nucleus, resulting in an atomic number of 2 less than the original. It's also known as radioactive decay. The most radioactive elements are 90 and above. However, 84 through 89 can also be radioactive, and a few others under 84, like cobalt, can be radioactive. Okay, so in this slide it asks you to identify the missing particle in the following nuclear reaction. So you have potassium-37, which has an atomic number of 19. So its mass is 37, its atomic number is 19, and we know that it is going to emit it's going to decay into a new atom or a new nucleus, and with a beta particle. So if you remember, when there is a beta particle involved, the atomic mass doesn't change. So we're going to look over here for an atomic mass that doesn't change. Well, A changes, so that means it's not that one. B does not change. C changes, so it's not that one. And D does not change. So the answer is either B or D. Now, we know with a beta particle that if you have to add or subtract one proton to get the new number. So if it's on this side of the equation, you're going to add it together. So to get 19. So 1 plus what equals 19? Your answer is going to be D, argon 37. Okay, let's go ahead and look at this one. So we have an unknown element that decays into an alpha particle, and I think that's thulium. So we know that the mass is going to change by 4, and the atomic number is going to change by 2. So 208 plus 4 is 212. So I'm going to look over here and look for masses that have 212. And I can see that my answer is either going to be A or D. And then my atomic number is going to increase by 2. So my new atomic number is 83. So I'm coming down here. I see the mass is 212 and the atomic number is 83. So the missing element is bismuth 212. Okay, here is another one where we have a americium. The mass is 241, the atomic number is 95, and it's going to go together with an alpha particle to create 2 neutrons and a different element. So if you've got 2 neutrons out here, that means the mass number is going to decrease over here by 2, and it's so we're going to add a americium and a helium, and so 241 plus 4 is 245, and the atomic number will become 97. So 245 minus 2 neutrons is 243, and the atomic number is going to be 97. So 243 and 97, here it is, A, our first element, berkelium. And that's it. And so now we get to practice what we've learned. Again, just a small reminder that an alpha particle is going to change the mass number by 4 and the atomic number by 2 because it represents a helium nucleus being emitted. A beta particle is going to increase or decrease, depending on which side of the equation it's on, the atomic number by 1, and a gamma particle is not going to change anything.